All right, so today's lesson is on piecewise functions. So our essential question is, how do I write and graph piecewise functions? So we'll talk about that.
Yeah, a piecewise function, it's a function that is a combination of one or more functions, like a piece of, think of a cake, right?
Oh,
You
yeah.
cut a cake up into different
Pieces.
pieces. Same thing with a function. We're cutting up the function into different pieces.
Okay.
The rule for a piecewise function is different for the different pieces
Makes
or
sense.
parts. So I could cut a giant piece of cake for Miss Young because Miss Young loves cake,
Or
and a teeny piece of cake for Miss Boy.
I don't like frosting.
And so there's different rules.
Yeah.
That's piecewise. A step function is, this is key, it is a piecewise function that is constant for each interval of its domain. That means, constant means a number. Constant, 3, 4, 5, instead of a variable.
Yeah,
oh, and look
get
what
rid
we
of
have
this.
here. We have a little surprise.
Oh boy, I thought that was gonna go away.
Should I do
Let's
it?
try again. I got her. Oh,
No.
Oh boy.
Here,
Okay,
let me
you
do
it.
this. Let's.
Okay, we got that taken
We're
care of.
back. So I'm gonna. You were saying something. Or are we good? Should we just move on?
Constant, just same number always.
Yeah.
Yeah.
When using interval notation, the square brackets, remember, means includes the endpoint, and parentheses means excludes the endpoint.
Right. So like a less than or equals is brackets.
Right.
Because it includes it.
Correct.
Got it.
Next page. On the next page, we are going to go to the next page. Right now, we're going to hit stop.
Oh, I just have to click here.
Oh,
And there.
there we go, Miss
All
Boyd.
right.
She helps me out. So we're going to create a table and a verbal description to represent the graph. Well, as you can see, we didn't make a table, so we're going to make a table right now. And we can do it anywhere you would like. So it says, because the endpoints of each segment of the graph identify the intervals of the domain, use the endpoints close to them as the domain values in the table. So we're talking about mixed nuts, we're talking about the weight and the price per pound. So we have an X, we have a Y. Our X is our weight, our price is our Y because it's on the Y axis. Right. So we're going to do what I like to do, Miss Boyd, is I don't like to do that. I like to do that.
I pick my own.
So I'm thinking our first interval is going to go from 0 to 2. See that? Because the first one goes, okay. So the 0 is going to have a bracket.
Okay.
And the 2 is going to have a parenthesis.
Okay. So am I not
right over there? Correct.
Right
yep.
Okay.
Bracket 0, comma 2 parenthesis. The reason the parenthesis, well, not a bracket. The reason the parenthesis on the 2 is because there is, and I'll have Miss Boyd point to it when she is done here to make sure you understand. Oh, that's okay. And will you point to the open circle on the 2 for them so they know what we're referring to?
Right.
Yes, correct. So how much does it cost per pound for a weight from 0 to 2?
8.
That is our Y. The next interval. So let's write a 6 for the price because we know it's 6.
Yep.
And now notice it's a closed circle on 2.
So bracket 2.
And it's an open circle on 5. So from 2 up to 5 pounds, but not including 5 pounds, it costs $6. Okay. And the last one will be 5. The price is 5. And the interval is a closed bracket on 5 and an open on
to infinity.
Yeah, it's always open on infinity.
Yep.
Correct. And you know, we did the closed circle on the 0. It didn't really matter because think about it. If I don't buy anything, I'm not going to pay anything. So now a verbal description is what we need right now down here. So basically what the verbal description is, it costs, so you can do steps 2, it costs $8 per pound.
Per pound.
Yep. For 0 to 2 pounds. And $6 per pound.
Can I just do
you can do whatever you want.
Like that?
For 2 up to 5. Not including 5. Okay? And $5 for 5 pounds and greater, or whatever. Yeah. So when we say up to, I want to make sure you understand, it's not
Can't
including the
include
5.
the 5.
Yep. So I think,
is that what we should do for the 2? Because it's up to
oh,
2?
shoot.
I'm
Miss
just gonna
Boyd,
write it right
I
here.
apologize. You're right.
Up to
Because it didn't include the 2.
2 points.
Correct.
Okay.
So we're going to save example 2 for class. And we're
Perfect.
going to go to the next page. And now what we're going to talk about is a piecewise function that is constant for each interval of its domain, such as the ticket price of going to like a movie.
Oh, yeah.
Is a step function.
Okay.
You can describe piecewise functions with a function rule. So for example, notice that our function right there, that is called a step function because there are no variables. Yes, in the interval there is, but each of the functions is equal to a constant. That is a step function. So what it's saying is,
These are our constants.
right, how you interpret this is, if you are under 13 years of age,
Yep.
you're going to pay $5 to go to the movies. If you are 13 and under 55, you're going to pay $9. And if you're 55 years old or older, you're going to pay $6.50. That's how you interpret it. That's a step function. Movie price, going
Got it.
anywhere, is a price of something.
Which is what they just
Yep.
put down there.
Correct.
Got it.
To evaluate any, now we're back to piecewise.
Mhm.
This is not example 3 is not a step function because you have 2x plus
Yeah,
1,
x's.
x squared minus 4.
So you gotta plug stuff in.
Right, to evaluate any piecewise function for a specific input, find the interval of the domain that contains that input and then use the rule. So basically what that means is this. Evaluate each piecewise function for, let's start with x equals -1. So let's
Okay.
circle that.
So first do this.
Right. So now we have 2 functions. Remember, a piecewise functions, you break it up into pieces. So which one are we going to use? The 2x plus 1 or the x squared minus 4? We have to decide that first.
Well, I put it in the first one. Does it matter?
It sure does.
Oh, because of this.
Yep.
X has to be less than or equal to 2. It can't
And
be
is
greater.
-1 less than or equal to 2?
It is.
Yes.
There we
So
go.
you plug the -1 only into the 2x plus 1.
Got
Okay.
it.
Now x equals 4, see?
Gotcha.
That
The
is
4
not-
has to go in the bottom one
Right, it
because
has
it's
to,
greater
because
than
it
2.
says, remember, my piece of cake versus Miss Boyd, they're different
Yeah.
sizes. Same thing here, these are different functions based on your x value, they're different.
Got it.
So we got 16 minus 4, which is 12. So our 2 answers we'll circle is -1, or box it, and 12.
Great.
Next page. Example 4, let's try this one.
Okay.
So again, x is -1. We're going to do that first.
Okay.
So
So
obviously,
it's got to be less than
or equal to. So we have to use the first
which
one.
is, yes,
Mhm.
this one.
Yep.
So we're going to plug in 2 to the -1.
Yes, we're plugging in -1 in for x.
Right.
We don't leave our answer like that, Miss Boyd. Because there's a negative exponent, we take the reciprocal, which is 1/2. There's our first answer.
Great.
X equals 4. That is
Greater
greater
than
than -1. So we will plug it into the 5x, which is 20. There's our 2 answers.
Great.
Now, notice the next one. It's different. So let's do it.
Okay.
See, these are piecewise because they have variables, 2 to the
Right.
x, 5x. This is, it says evaluate the piecewise function, but it's also a step function.
Because there's no
Mhm.
variable.
So when x is equal to -1,
Let's see
which
one
one are we
So
going to
it has to
use?
be less than -3, so that doesn't work.
Mm-mm.
It needs to be greater than -3, but less than 1, or
Right.
less than 6.
Yes.
Ooh, this one would work.
Mhm.
Or
But
greater than 6.
I don't-
So it's this one.
But I'm confused because it says x is -1, and before we would plug x into something,
Yeah,
but there is nothing to plug
we just
in.
take the answer.
You got it.
It's just 15.
And how about x equals 3?
X equals 3. So it's got to be
In the same one.
the same one. Because
So
it's gotta
guess
be
what?
Less than 6,
We have
but greater
2.
than.
So what I'd like you to write down below for me for a minute,
Yeah.
could you write the f, maybe go in, sure, f, and in parentheses write -1. That equals 15. And down below, f3 equals 15, just so they understand.
Okay.
So we're evaluating the function when x is -1 and 3. And the answers are the same because it
Exactly,
is
so we're
a
done.
step function.
Great.
Example number 6, we are going to,
We'll
what do you
leave
think?
it, 'cause
Should
you're
we,
just plugging it in like we
let's
did before.
hold
Yeah,
off.
let's
Yeah. Example 7. Ooh, look at this. Oh, we have to do this.
Okay.
You can graph a piecewise function by graphing each piece of the function. Now, Miss Boyd, this is what I like to do on these.
Sure.
Students know how to graph lines.
Mhm.
So I like to graph both lines and then
Great.
I erase the part I
Okay.
don't need. So let's graph
we'll
the
do
first
this.
line.
We'll do it in red.
So what's the
So
the
y-intercept's
y-intercept?
at 3, and then our slope is
Up
up
1.
1 over 4, or
Right.
down 1 back 4.
Yeah.
1, 2, 3, 4.
Right.
I guess 1, 1, 2, 3, 4.
And is it, oh, hold on, I have to think about this. No, nothing, never mind,
Yeah,
never
no,
mind.
no,
Sorry.
Don't mind our
I'm-
daily announcements. We're just going to finish
Yep.
this up.
Okay, now let's change our color.
So we have 3,
Yes.
and then down 2 over 1.
Right,
Down 2 over 1.
correct.
Okay.
And we're graphing. Now is where we're gonna
Yes.
stop
We're going to erase.
because it says x must be less than 0. So for
it
the
must be
red graph,
everything to
we
the
need an
left.
open circle.
Okay.
Okay, so for red, go back to red, we need an open
I'm just
circle
gonna
right
do
there.
this.
Because that's where x is 0.
Yep, it's very less than.
So you're going to erase everything to the right.
Okay.
So we got that one covered. Now let's go to the blue one. Let's change our color to blue.
Yep. It needs to be
Now it's a
equal.
closed circle. So we're kind of doing an open circle and a closed circle. See, so maybe do an open circle around that in red just so they remember. Okay, so now x is greater than or equal to 0.
So that
So
means it has to be
hold on. You're going to want to erase
right.
this.
It's got to be greater than or equal
Right,
to.
correct.
Great.
Okay, and that
Alright.
is your answer.
Good.
So example
So I
8,
think
we're
we'll skip.
saving and 9.
Yep.
And
And
video
there are your video
questions.
questions.
There you
So
go.
See you tomorrow.
Yeah, bye-bye.
Bye.